Today we're going to do coin problems, and we're going to be dealing with two unknown coins, nickels, dimes, quarters, pennies, whatever they tell us. And currency that we know how it works, penny's worth a penny, nickel's worth 5 cents, dime's worth 10 cents, quarter 25 cents, half dollar 50 cents, a dollar's worth 100 cents, and so on and so forth. Yeah, it's crazy. I know, but anyway, they're going to use American currency. If they don't, then they'll tell you what the currency is worth in order to be able to do this. But the main idea here is we're going to be given two facts about these coins. We have to create two equations based on the facts. And what makes these problems slightly different from other problems we've seen before with two unknowns in them is that the facts are going to involve different types of things. So, let me show you what I mean by this. Jack and Betty have 28 coins that are nickels and dimes. Alright, what they're telling us there is not only how many coins there are, but what type of coins they are. Nickels and dimes, that's important. So, what I want to do here is I'm going to put nickels and dimes as my unknowns. And over here, I'm going to put number, because that's what that's telling me. How many coins are there? Alright? Do we know how many nickels or dimes Betty have, or Jack and Betty have currently?
No.
We know together they have 28, but there might be 1 nickel and 27 dimes. There might be 25 nickels and 3 dimes. I don't know individually. So I'm going to say that they have N nickels and D dimes. Okay.
And the total is 28?
Well, we'll do that in a minute. Yeah, the total of those is 28, yes. All right. But for now, if I say how many nickels do they have, the correct answer is N. If I ask how many dimes they have, the correct answer is D. So all we're doing is we're inventing an answer for the problem to represent how many nickels and dimes they have. And then, if you continue reading, it says the value of the coins is $1.95. It should have a little dollar symbol in front of it. Does yours have a dollar symbol in front of it?
No.
Pretend there's a dollar symbol in front of it. All right, $1.95. Now, here's the deal with nickels and dimes. How much is a nickel worth?
5 cents.
5 cents. Okay, 5 cents looks like this: $0.05 or 5 cents. Which one do you think is easier to work with?
5 cents.
5 cents is easier to work with. So, what I want to do is I want the value of these coins, but I want it to be in cents, not dollars. Right? So, just a moment ago I told you exactly how many nickels we have, and that answer is what?
N.
N. Very good. Alright, if I have N nickels and every nickel's worth 5 cents, how much money do I have in nickels?
5N.
5N. Same question for dimes. If I have D dimes and I'm 10 cents per dime, 10D is the value of the dimes. Right? So, what we've done is we algebraically invented an answer for nickels and dimes, how many we have, and based on how money works, 5 cents times how many nickels, 10 cents times how many dimes, that represents how much money we have in both of these things. And if we take a look at the two facts they gave me, fact 1 is we have 28 coins. 28 coins has to do with how many coins, numbers, we use the number variables, N plus D is equal to 28. So we just take a fact based on what it's telling me to create an equation. The second fact they give me is $1.95 is the value of those coins, so the value of the nickels plus the value of the dimes is equal to the value of the coins. Now be careful here, this is $1.95, right? Which is the same as 195 cents. So just the same as this, $1.95 is equal to 195 cents. Alright, so be careful that we do change the unit from dollars to cents. And what we've created here is a nice little system of equations. Elimination or substitution is alive and well in this problem. We can use those.
Elimination.
And one thing before I even do elimination, which I will want to do, because it's set up better for elimination. Notice the red equation on the bottom. 5N plus 10D is equal to 195. Happens very often in coin problems. Every number divides evenly by 5. That is legal, and making numbers smaller is worthwhile. So if I go N plus D is equal to 28, keeping the top equation as is, divide by 5, divide by 5, divide by 5, I'm going to get N plus 2D is equal to 39. So the system of equations in black is equivalent to the system of equations in red and blue over there. But again, this is easier to do. And again, with coin problems, this happens almost all the time. Except for pennies. Every other coin divides by 5, so that should happen quite often, so look for it. N and same, they're supposed to be opposite, so I'm going to change that to negative, negative, negative. Could also change the signs of the top equation, doesn't matter. If I add the equations together now that I've made everything opposite on the bottom, n minus n cancels. D minus 2d makes negative d. 28 minus 39 makes negative 11. So if minus d is negative 11, then positive d is equal to positive 11. So we have 11 dimes. How many nickels?
17.
How do you know 17, Parker?
Because math.
And
Subtract
specifically?
it. You subtract 11 from 28.
Very nice. Okay, we know there's 28 coins. We just figured out there's 11 dimes. 17 plus 11 makes 28, so we have 17 nickels. Okay. The extra nice thing about coin problems is that you guys have been using money a lot of your life, right? I don't know if you were 2 years old and going to the store buying stuff, but probably in the last 5 or 6 years you've probably gone to the store several times buying stuff and you understand how money works. We can very easily check this to see if we have the right answer. We have 2 facts that are supposed to happen here. Number 1, we're supposed to have 28 coins of nickels and dimes. 11 plus 17 is 28 coins. Fact number 1 checks out. Fact number 2, the value of these coins is supposed to be exactly $1.95. 11 dimes is $1.10. 17 nickels is equal to 85 cents. Add them up, you get $1.95. Okay, you can very easily check to make sure you have the right answer once you get the right answer. So it's one of those self-checking problems. Again, the answer they're looking for is this, but again, you're welcome to check to verify that both facts do occur with